Hello guys, welcome to my channel. My name is Aditya Jalva and my USN is 1V22CA006. Today I'll be explaining exceptions, interrupts and vector interrupts. Introduction to exceptions, interrupts and vector interrupts. Definition of exceptions, interrupts and vector interrupts. Exceptions are deviations from normal program execution. Interrupts are signals demanding immediate attention, and vector interrupts are specific memory locations for handling interrupts. Significance in computer and embedded systems. These concepts are vital for error handling, real-time processing, and resource allocation in computer systems and embedded devices. Real-world applications. Exceptions are used in programming languages for error management. Interrupts handle hardware requests, and vector interrupts are crucial in managing priority levels. Exceptions definition and types. Definition of exceptions. Exceptions refer to unexpected events that occur during the execution of program, disrupting the normal flow of operations. Synchronous versus asynchronous exceptions. Synchronous exceptions are triggered immediately at the point of occurrence, while asynchronous exceptions are delayed and handled separately. Example of common exceptions. Common exceptions include divide by zero, where a number is divided by zero, and invalid memory at access, when a program tries to access unauthorized memory locations. How exceptions work. The process of handling. Exception handling refers to the mechanism in programming that deals with runtime errors to prevent abrupt termination of the program and ensure graceful error recovery. Steps involved in exception processing. Exception processing involves identification, propagation, and handling of exceptions through structured mechanisms such as try-catch blocks to maintain program stability and reliability. Role of processor and OS in handling exceptions. The processor and operating system play crucial roles in managing exceptions by executing exception handlers, providing necessary resources, and coordinating error resolution. Interrupts definition and importance. Definition of interrupts. Interrupts are signals sent to the CPU to temporarily suspend the current program and execute a special program known as an interrupt service routine. Importance of interrupts in multitasking and real-time systems. Interrupts play a vital role in allowing multiple tasks to run simultaneously in multitasking environments and ensuring timely responses to real-time events without delaying critical processes. Hardware versus software interrupts. Hardware interrupts are generated by external devices to request attention from the CPU, while software interrupts are triggered from software instruction during program execution. Vector interrupts, concept and usage. Definition of vector interrupts. Vector interrupts are a type of interrupt in computer system that provide the address of the corresponding interrupt service routine directly to the CPU. Differences with regular interrupts. Vector interrupts differ from regular interrupts by offering a specific address for each type of interrupt, enabling faster and more efficient error handling of multiple interrupts. Examples in embedded system. In embedded system, vector interrupts are commonly used to manage real-time events such as sensor inputs, enabling precise and time response to critical signals. Interrupt handling mechanisms. Hardware and software components. Involvement of both hardware, interrupt controller, and software operating system components in managing interrupts. Interrupt service routines, ISRS. Dedicated routines that handle interrupts by performing tasks associated with interrupt requests. Example of interrupt handling sequence. Illustration of a step-by-step process showcasing how an interrupt is detected, acknowledged, and serviced by the system. Comparison of exceptions and interrupts. Key differences. Exceptions are unexpected events disrupting normal program flow. Interrupts are external signals requesting attention from the processor. Handling mechanism similarities. Both trigger a change in program flow to address specific events. Both require specific routines to handle the event and resume normal execution. Preferred use cases. Exceptions are preferred for critical errors requiring immediate attention. Interrupts are suitable for hardware-related events like I/O operations. Challenges in handling exceptions and interrupts. Timing issues and latency. Dealing with timing concerns and delays affecting exception and interrupt handling processes. Complexity in nested exceptions and interrupts. Navigating through intricate scenarios involving multiple layers of exceptions and interrupts, posing challenges in resolution. Debugging and testing challenges. Addressing difficulties in identifying isolating, and rectifying issues related to exceptions and interrupts during debugging and testing phases. Best practices for exception and interrupt handling: ensuring minimal latency. Implement strategies to minimize the delay in interrupt processing, enhancing system responsiveness. Design considerations: incorporate design principles that prioritize system reliability and fault tolerance for seamless operation. Robust exception handling. Develop and apply resilient exception handling mechanisms to maintain system stability under unforeseen circumstances. Thank you for watching my video. See you in the next one.